that brings a complication into the whole process in terms of development and testing and possible failures. And some people just avail to not to do it at all, so they just don't do it. It's simpler, faster, requires less resources on the device, but it's not secure. It pretty much means that anybody can take over the connected device. So when I mentioned the encryption and authentication, these are two different things. Encryption, that means that the traffic on the wire goes encrypted. Authentication means providing a proof that I am who I am. So, and these two different problems are solved with an industry standard solution called SSL TLS. This is the protocol that solves both problems. TLS can provide encryption, and also TLS can provide authentication. So, but there is a cost in using TLS. The cost is obviously a complexity. Making your firmware doing TLS and encrypting the traffic and providing authentication is a hassle. So it's harder to program that. And it's more points of failures during the process. And the second thing is the performance. So just to get to know the audience, how many of you are developers who actually develop? Okay, cool, thank you. So not like pretty much half and half. So I'll not be using the specific terms, but basically just to talk about the performance. If you use the least secure TLS setup, which means no key exchange, that means 1024 bit key. Some typical device can perform the TLS handshake, the initialization of secure session, in about 2 seconds. If you use a bit more secure setup, it goes to about 8 to 10 seconds. And if you use even more secure setup, which corresponds to the current standard of security, that goes up to about 30 seconds. Which is not good, obviously. So that means that every time a device wants to create, just and establish a new TLS connection to the backend, it's half a minute to wait. Not good. And another thing is the authentication, the two-way authentication. So what is that? The TLS provides a way of authentication, which is similar to login password. So you probably, all of you, used online shopping with the SSL secured websites with a nice green address bar, which says it's secure and all that stuff. So how does it work? It works this way. Every browser that you install, it has a predefined set of so-called CA certificates. Every browser has it pre-installed. And these certificates are used to verify the identity of the TLS server. So when you connect to Amazon.com, for example, the Amazon.com website sends you a certificate saying I'm Amazon. It authenticates itself. Amazon says, trust me, I'm Amazon.com. And the browser, having these CA certificates, verifies, okay, this guy says it's Amazon, yeah, it's Amazon. There are like crypto algorithms that do that. And if the verification is right, the browser puts a green bar on top of the address bar. So, and not many people realize that the same process could be done another way, right? So the server can do the same thing for the client, right? So the server could verify the identity of the client that connects to it. Usually when you shop online, it's not needed. So Amazon doesn't care who you are. The main thing that you buy from them, right? And who you are doesn't care, it doesn't matter. But in this case, when you talk about the connected products, server does care. So the server might want to verify, is that device really a device that I want to allow in my network or not? So in this case, the client side has to have a certificate which plays a role of that proof of login password thing. So and it's called two-way TLS or two-way SSL. You probably heard that term, but basically that's what it is, roughly speaking. So it's not only client, it's not only server that says I'm the one. It's also a client says I'm the trusted one, and server verifies that. So that client certificate is stored on the firmware. It should be stored on the firmware, and it's basically kind of like a password. It's sensitive. It should be protected. It should not be read by somebody. So if somebody takes a device and just reads the flash drive from it, and if the client certificate stored their plain text, that they can use that certificate and connect to the same cloud impersonating that device. So that's not secure. So using certificates is more secure than not using them at all, but storing the client certificates unprotected is a bit less secure than storing them protected. So what are the options? So option one, don't care, like, okay, that's fine. We're gonna store these certificates, kind of password-like things, on the firmware unprotected. That means that anybody can steal it, but that's fine. So this is a compromise, a possible compromise. Option two, use the hardware that allows to store, to encrypt the flash drive on a device. Some of the chips that do that, for example, in ESP32 chip, which is fairly popular, which is excellent by the way, it can do that. So in this case, anybody could, that gets the physical device and reads the flash is going to be just garbage on the flash. And option three is to use a specialized crypto chip. So what specialized crypto chip does? It's a fairly interesting piece of hardware. It's a device that can be, that you can write a certificate to, you can write a private information to it, but you cannot read it from. So you can write, but you cannot read. And also it has a layers of anti-tampering protection. Anti-tampering protection means that if you try to hack into it, physically break in, the device either locks itself or basically it has like layers of protection to prevent reading this private information from it. So and then when the software that does SSL connection needs to encrypt the data, it basically gives that data to the crypto chip and says, okay, you have the private key, I don't. Here's the data just encrypted inside. So, and the crypto chip does that itself. And so that the private information never gets out of the crypto chip. So, and that makes using the crypto chip a fairly secure option. And that's what we did. So, we used we used one of the crypto chips. There are many crypto chips, but one of them, it's called ATECC508A from Microchip, which was designed specifically for AWS IoT. It's fairly cool, and one of the best points of using the chip is its price. So it's cheap. It's less than $1. So you can buy it just one piece for 80 cents. And in that particular project, we use ESP8266 chip as a Wi-Fi solution. So together, ESP8266 plus this microchip crypto module, it made this bundle the cheapest secure option right now available to work with AWS IoT. So ESP8266 is a very popular module. It costs about less than $2. Together with microchip that costs less than $1. Basically, you can get a secure solution for about $2, which is great, which is fantastic. And that solution has been featured in reInvent conference, Amazon reInvent conference this December. So yeah, there is a video link I put together there. So this is basically it. So what we went with the crypto chip solution, which is one of the most secure ways to make the cloud connectivity